Hello friends, welcome to Physics Life channel. Today we are discussing about the fundamental forces of nature. So fundamental forces of nature, we know that uh, first of all the fundamental forces, first force that is we are discussing about the strong force. Strong force as also known as strong nuclear force. Strong interactions is very strong but very short ranged, that is it is strong short ranged but it is strong. It is responsible for holding the nuclei of atom together. It is basically attractive but can be effectively repulsive in some circumstances. Mesons are the force carrier for it in the case of nucleon, and gluons are the force carrier in the case of quarks. Okay, thus even the quark inside the protons and neutrons are bound together by the exchange of strong nuclear force. The relative strength is 1. Time frame for this is 10 raised to minus 23 second. It obeys all the conservation rules. Isospin, a hypothetical concept, it is responsible for this force. This force is charge independent and then spin dependent, and also it always saturates. So we discussed in strong force, that is it is very strong and it is short range, and we have to know that is gluons are the force carrier in the case of quarks, and the time frame is 10 raised to minus 23, and relative strength is 1 for this. It is charge independent and spin dependent. It is the force holding the nuclei of atom together. This is the first force, first fundamental force we discussed. And next we are going to the electromagnetic force. The electromagnetic force causes electrical and magnetic effects such as repulsion between like electrical charges or the interactions of bar magnets. It is long ranged but much weaker than strong force. It is the attractive or repulsive and acts only between pieces of matter carrying electric charge. Electricity, magnetism and light are all produced by this force. Relative strength is order of 0.01. Time frame is, this is 10 raised to minus 16 to 10 raised to minus 21 second. All conservation rule are obeyed except the isospin. The charge is responsible for this force. Photons are the force carrier. So we have to understood from electromagnetic force, that is we have to consider only the charge particles for this force, and it is weaker than strong force but it is long ranged, and relative strength for this, that is 0.01, and time frame from 10 raised to minus 16 to 10 raised to minus 21. Okay, and what is about this force carriers? Force carriers as photon for electromagnetic force. For strong force, that is gluon. Okay, next we studied, that is weak force. Weak force is responsible for radioactive decay and neutrino interactions. It is a very short range, and as its name indicates that it is very weak. The weak force causes beta decay, that means conservation of neutron into a proton and an electron and an antineutrino. The relative strength is in the order of 10 raised to minus 10. The time frame for interaction is 10 raised to minus 7 to 10 raised to minus 10 seconds. Many observation rule is violated. Spin is responsible for this force. Vector bosons are the force carriers. Force carriers are Z0, W plus and W minus. So weak force, it is weak, very weak force, and it is responsible for beta decay. And what about this force carriers, that is vector boson Z0, W plus, W minus. Okay, it is very short range force, weak force. Okay, and also strong force is what is strong force is also a short range force. Gravitational force, it is weak but very long ranged. Furthermore, it is always attractive. It acts between any two pieces of matter in the universe, since mass is responsible for this force. Relative strength is 10 raised to minus 40. Force is mediated by hypothetical graviton spin to particle. So about gravitational force, it is weak but it is long ranged force is gravitational force, and it is always attractive. And what about this force carriers? That is hypothetical. Graviton is the force carriers, that is spin to particle, and the mass responsible for this gravitational force. For weak force, spin is responsible for the weak force. Electromagnetic force, that is charge is responsible for electromagnetic force, and strong force for isospin is responsible for this force. Okay, so we have studied the four fundamental forces in nature, that is strongest force, that is strong force, and then electromagnetic, then weak, and gravitational force is weakest. Okay, next we are going to the nuclear terminology. And nuclei we have we already know about, that is Z is representation of atomic number, which is equal to the number of protons, and N, capital N represents the neutron number, that is number of neutrons. Capital A, that is mass number, that is number of nucleons. So we know that mass number A is equal to Z plus N, that is proton number plus neutron number. And we know that charge on the nucleus is Ze, that is atomic number into absolute value of electric charge on the electron. Nuclei with the combinations of these three numbers, it is known as a nuclide, and it is written as like this. And here we can represent neutron number also in right hand side, lower side, and X is in which expresses a chemical element, and A is mass number, Z is atomic number. And this is some examples of isotope, isotone, isobar, and isomer. That is we should know about already about this isotope and isotone, isobar, isomers. Okay, so next there is a trick which discusses in this note. The note is prepared by Dr. Ubakul Muhanda. He introduces a note, that is if you want to study what you mean by isotope, it is the number of protons are same. So P, the isotope in which P is the number of protons are same. For isotone means N is a neutron, so same number of neutrons. And isobar, bar in which A is there, so A is responsible for capital A, that is mass number, so same mass number for isobar. And next, that is isomer in which E is energy, but here the energy of the nuclei is different, not same like earlier cases. Energy different cases for isomer. This is some simple trick we know about this isotope, isotone, isobar, etc. So next we are considering, that is atomic mass unit. Atomic mass unit. An atomic mass unit is defined as precisely 1/12 of the mass of an atom of mass of an atom of a C612. In precise terms, 1 AMU is the average of proton rest mass and the neutron rest mass. Okay, so this is approximately 1.67 into 10 raised to minus 27 kilogram. And 1 AMU is equal to, we want to study like this, 1.66054 into 10 raised to minus 20.